Hello, thanks for clicking. Welcome to another Nargilus 2 production. Today we're going to be using vectors and component calculus to solve motion problems. So solving motion problems is something that you did probably in Calculus 1, where you looked at position, its relationship to velocity and acceleration. Now we're going to do the same thing, but with component calculus. So it's very similar to what you've already learned. So let's take a look and we'll give it a shot. So if you remember, you have x of t would be your position function. The derivative of x of t would be your velocity function. And then if you find the second derivative of the position or the first derivative of the velocity, you get the acceleration function. But if you have something written as a vector, its position vector, has two components, an x component and a y component. Then its velocity vector will also have two components, okay? X prime and y prime. So to find the velocity vector, you just derive the position vector in both directions. And then the same thing for the acceleration vector. Derive the position vector twice or the velocity vector once. Okay? The other thing you do need to know is that speed is the magnitude of the velocity, and the magnitude of the velocity is the square root of dx dt squared plus dy dt squared. Okay? All right, so let's get started. We'll see how this works. So here's a problem. At time t, we're going to use this scenario for the entire video today. You're given a position, x of t, y of t, but x of t and y of t are not given. You don't know what they are. However, you do know dx dt and dy dt. So you actually know the velocity vector, right? Okay, if I were to put 4t squared plus 1, comma, t sine t squared, that would be my velocity vector for this position vector that I have. All right, and we're given some initial conditions as well that we'll use as well. So in letter A, they want you to find the speed of the particle at t equals 3. Well, to find the speed is the square root of dx dt squared plus dy dt squared. All right, so I know what dx dt is, so let's just take dx dt and evaluate it at t equals 3. If we do that, we get 37. And if I find dy dt at t equals 3, I get 3 sine 9. So then the speed would be the square root of 37 squared plus 3 sine 9 quantity squared, all under the square root. So now you can, this would be your exact answer. You could type this into a calculator. It would give you a decimal answer if you needed it. And that's how you find the speed of that particle. Okay? All right, using both directions. All right, let's try another part of this. Let's write the acceleration vector at t equals 3. Okay, so dx dt is 4t squared plus 1. Dy dt is t times sine t squared. The acceleration vector will be the derivative, a of t, will be the derivative of the velocity vector. Well, the velocity vector is the vector 4t squared plus 1 and t sine t squared. So there's my velocity vector. To find the acceleration, I need to derive each component. Okay, so the derivative of 4t squared plus 1 is 8t. And then over here on the side, let's derive t sine t squared. We need the product rule for this. So we'll leave the first one there. Derivative of sine t squared is cosine t squared times 2t plus, leave sine t squared there. The derivative of t is 1. So the acceleration vector would be 2t squared, 2t times t, 2t squared, cosine t squared plus sine t squared. So there's my acceleration vector. Now I want to evaluate that acceleration vector at t equals 3. So a of 3 would be 24, comma, 2 times 3 squared, cosine 9 plus sine 9. So that would be 24 in the x direction. And then it would be 18 cosine 9 plus sine 9. And again, that gives me my exact answer. You could type this into a calculator if you needed to get a decimal approximation. But that's how you evaluate the acceleration vector at t equals 3. Okay? So again, these are all things you know. We're just doing it now with multiple components. All right, let's find the position of the particle at t equals 3. Well, the position, this is the velocity vector, right? These two components together represent the velocity. To get from velocity back to position, I have to integrate. Okay? And then I have an initial condition in both the x direction and the y direction. So to find x of t, I could take 0, that's my starting position, plus the integral from 0 to 3 of 4t squared plus 1 dt. All right, so that would be straight line from 0 to 3. I could just integrate this. 4t cubed over 3 plus t. And then I'm going to substitute in 4 times 3 cubed over 3 plus 3 minus, if I substitute 0 in, I get nothing. And if I clean that up, one of these drops out with one of those, makes it squared. It's 36 times 36 plus 3 is 39. Right? So x of 3 will be 39, comma. Okay, now let's do it in the y direction. In the y direction, I'd have to, I'm starting from -4 plus the integral from 0 to 3 t sine t squared dt. So over here in this integral, I need substitution. I could let u be, oh, spoiler alert, let u be t squared. And then du is 2t dt. Need a half for Beach Boys. So y of t, or this is really y of 3, would be -4 plus, let's change the bounds around. If t is 0, u is 0. If t is 3, u is 9. And we need a 1/2 out here. And we have sine u du. Okay, so that's -4 plus 1/2 from u equals 0 to u equals 9. The integral of sine is minus cosine. So that's going to be -4 plus 1/2 negative cosine 9 minus negative cosine 0. Cosine of 0 is 1. So that's -4 plus 1/2 negative cosine 9 plus 1. And again, you could type that in a calculator if you needed to. I'm not going to do that. If I distribute the 1/2, though, that would allow me to get -3.5. So that's -3.5 minus cosine 9, half of cosine 9. And that would be the position of the particle at t equals 3 in the y direction there. And this, overall, is my position of the particle at t equals 3. Okay? All right, and then finally, let's find the total distance traveled on the interval 0 to 3. So to find the total distance, d, I'm going to integrate from 0 to 3, and I'm going to integrate the speed with respect to time. So I'm going to integrate from 0 to 3, the square root of, so remember your speed formula is the square root of dx dt squared plus dy dt squared. Dx dt is 4t squared plus 1, so we have 4t squared plus 1 squared plus dy dt is t sine t squared with respect to t from 0 to 3. And if you type this in a calculator, you get 39.145. And that should be your answer if you type this into the calculator correctly. All right, and that's it. So basically, we're taking something that we learned in Calculus 1 and applying it with multiple components. Okay? As always, thanks for clicking.